Live from the Thinkubator at the Tech Valley Center of Gravity, this is STEAM Powered Saturday, a free monthly event where children ages 4 to 12 and their families are invited to join us for a fun, creative, hands-on project. These mind-exploring projects help children discover creative play through science, technology, engineering, the arts, and mathematics. This month, we're on the internet. Now your host, Dan the Science Man. Rainbows. Where do they come from? Why are they so beautiful? We'll answer these questions and more. Before we start, we want to thank the Albany Society of Engineers Foundation for their generous, ongoing support of STEAM Powered Saturday. Our special virtual editions are brought to you through additional sponsorship from GE Healthcare in Troy, New York, and Agora Media. Now, for the next few months, we will be hosting STEAM Powered Saturday online and focusing on projects that you can do at home with materials you already have. This month, we were inspired by the 518 rainbow hunt, so we will be learning all about rainbows and how they are formed in nature. But before we can learn about rainbows, we have to learn a little bit about light and color. Visible light, that is, the light we can see, is actually made up of colors: red, orange, yellow, green, blue, indigo, or dark blue, and violet, or purple. You might notice that these are all the colors in a rainbow. This is called the visible spectrum of light, since these colors are the ones that we can see. So, how do we know that white light is made up of all these different colors? That's all thanks to a man named Isaac Newton, a scientist who lived from 1642 to 1727. Isaac Newton conducted research on the sun, light, and color. Isaac Newton was experimenting with glass prisms, like this one. A prism is a triangular clear object. Isaac was able to discover that if you shine white light through one side of a prism, colored light will come out the other end. You see, when light passes through a prism, it bends and reflects off the different sides, which breaks the light up into different bands of color. This is called refracting light. Objects are different colors because they absorb some color wavelengths and reflect others. For example, when we look at this apple, it appears red because it reflects red light and it's absorbing all the others. When we look at this orange, it is reflecting orange light and absorbing all the other colors. This paper is white because it absorbs none of the colors and reflects them all back to us. This paper is black because it's absorbing all the colors, so we don't see any of them. So, where do rainbows come from? Well, sunlight is just white light, so when sunlight is refracted, rainbows occur. You might have noticed that rainbows show up after it rains and the sun starts shining. The sunlight is actually refracted through raindrops that are still in the sky. For a rainbow to appear, the sunlight must be behind us and raindrops must be in front of us. The sunlight refracts on the droplet of water, then reflects inside the back of the droplet, and finally refracts again upon leaving the droplet. When white sunlight gets refracted through the raindrops, the bands of color become visible to the human eye. But you don't need to wait for the rain to find a rainbow. Dan, our senior rainbow correspondent, will show you how you can make a rainbow at home. Dan? Thanks, Dan. So, we're going to do some experiments that will allow you to create a rainbow at home. Now, in order to do this, we're going to need to use either the sun or an LED flashlight. So a word about safety. You never want to stare directly into the sun or stare into a mirror that's pointed at the sun. The sun is very powerful and its rays can damage your eyes. Some LED flashlights are also very powerful, so you never want to stare directly into a flashlight. The experiments we're going to do are going to try to recreate a prism. You'll recall from what Dan said earlier is that a prism is a glass or plastic triangular shape. Light enters it, it reflects around, and the light waves separate into the different colors. So we're going to try to recreate that prism effect by having light bounce through different surfaces, and we're going to see if we can make some rainbows. For our first experiment, you're going to need a container that's half filled with water, a mirror that is placed in the water at an angle, and then a flashlight, or you can bring it outside if it's a sunny day, and then a white piece of paper. You're going to shine the flashlight straight through the water onto the mirror, and you're going to try to get a rainbow to appear. So the light is going to bounce through the water and off the mirror, and a rainbow is going to appear somewhere above you. So you're going to hold the white paper above the bin or the container. So you might have to play around with the distance the flashlight is from the mirror and the angle. But I found if you hold the flashlight kind of far away from the mirror and maybe not shine directly on it, you can get a pretty nice rainbow. Look at that. For our next experiment, you're going to need a clear, smooth glass that is filled with water. You're going to need some white paper, some tape, and some scissors, as well as your flashlight. So you're going to start by cutting a slit in a piece of paper. So you can fold it in half, cut 2 lines in it there, and then just rip out the piece of paper. And you can experiment with different size slits to see what's going to work better. And you're going to take a piece of tape, and you're going to want to tape the piece of paper so half the slit is over the water and half the slit is beneath the water. And with your flashlight, again, you're going to have to play around with angles, moving the flashlight around. But you'll see you're going to look for a rainbow somewhere right at the bottom of the glass. So you can see there's a little bit of a rainbow starting to show up. So this experiment is a little bit tricky, so if you don't get it the first time, don't get frustrated. Just keep trying and keep experimenting. Our last experiment involves a compact disc, or CD as we called them back in the day. Now, a CD is nothing more than a piece of clear plastic with a really, really, really thin piece of metal sandwiched in the middle. So when we shine light on it, the light is refracting through the clear plastic, hitting the shiny metal on the inside, and then reflecting back out. So if you look at the shiny side, you'll see a whole bunch of rainbows appear already. But what you can also do is bring your CD out into the sunshine or use your flashlight, and you should be able to get some nice rainbow colors reflecting onto your piece of paper. So you'll see this one, we're getting a nice rainbow triangle and a little bit of an actual rainbow, circular rainbow shape. Cool. So those are a couple different ways that you can make rainbows at home. I'm receiving some breaking news from our weatherman, Dan. Dan, what's the story?
Thanks, Dan. We are out here in the weather, and we have just learned that the Tech Valley Center of Gravity wants to see your rainbows. So make your own unique rainbow sculpture using whatever materials you have at home, paper mache, markers, rocks, whatever. Take a picture of your creation and send it to the Center of Gravity either by email, thinkubator@tvcog.net, or on one of their social media pages, either Facebook or Twitter, with the hashtag CogRainbowHunt. They will print out your pictures and hang them in the windows for everyone to see in the 518 Rainbow Hunt. So for inspiration, here's one I made earlier today. You'll see it is made of pipe cleaners and some fluff and a piece of paper, glue. I'm really proud of it. It's probably one of the best things I have made in a long time. Now, the contest is open to kids 12 and under, and they will be taking submissions until May 1st. And 5 lucky winners will receive a free STEAM basket and a free 3-month Thinkubator membership at the Tech Valley Center of Gravity. Back to you, Dan.
Thanks, Dan. That's excellent news.
Can I come inside now?
No.
Oh.
Well, that will do it for this month's edition of Steam-Powered Saturday. After some reflection, I think you will agree that it was pretty enlightening. We'd again like to thank our sponsors, the Albany Society of Engineers Foundation, GE Healthcare in Troy, New York, and Agora Media. We're looking forward to seeing all of your rainbow creations. Good night, and have a colorful tomorrow.